Hello and welcome to the McHale Report podcast. My name is John McHale, Group Editorial Director for Military Embedded Systems and host for today's event. Our guest today is Clif Basnight, Vice President, Strategic Technologies with Ultra Intelligence and Communications. And we're going to discuss MOSA, defense acquisition, Sentient radio, and much more. So let's get started. Clif, welcome. I'm excited to have you on. This is something you and I have talked about doing for a while. I'm very familiar with you, but can you tell our audience a little bit about your background in the defense industry and your responsibility within Ultra?
John, it is an absolute pleasure. We really have been talking about this for a while, so it's great for us to come together. Just a little bit about myself. I kind of break myself down in 10-year increments. The first 10 years I spent as a soldier. I started out as a mechanic in the Army. Somehow I was in the right place at the right time, became a vocalist in the Army band. And then after that, I got lucky again and was selected to be an intelligence analyst and also an intelligence analyst for the Army. And they put me in a place where I specialize in intelligence communication systems, the actual communications behind a lot of the sensors that feed the intelligence community. And that's where I learned where I picked up the knack of doing connectivity and communications. And from that, I moved out of the enlisted world into the government. So I was in the government for another 10 years. Let me go back one second. Before I left my enlisted career in the Army, I was in the Force 21, which is the Army's first real division modernization effort that happened from the late 90s into the Iraq War. And so I transitioned out of that, went into the government, and then became a systems engineering architect. So I was able to be a part of the Army's modernization around Army Battle Command systems, the Joint Tactical Radio System, the Future Combat Systems, as well as capability sets. So all of the things that you've read about in the news, I got to be on the ground for when they were first being instantiated. And after I transitioned out of the government, because I was given some amazing opportunities, I transitioned to industry. And for the last 10 years, I've been a strategic technologist. I was able to lead stuff like LEO terminals, our foray into the integrated tactical network, mobile connectivity and expeditionary command posts. And now where I sit, doing hyper-connected architectures based upon high-capacity radios, troposcatter, cellular, and multi-band, multi-orbit satellite communications pieces. So that's me in a nutshell.
And on top of all that, you can sing. So I did not know that part.
I'm a mean karaoke guy now, but the Army used to pay me to sing and dance.
That's fabulous.
Yeah.
So one of the things that we've talked about the last couple of times we've seen each other is the DoD's modular open systems approach, or MOSA mandate, to leverage open architectures and all new programs and tech refreshes. And I know you're a big proponent of that. We've had those chats and also within SOSA, which is Sensor Open Systems Architecture Consortium, where you guys are playing. But why does MOSA have so much momentum in the defense industry right now, and how does it benefit the warfighter?
So here's the long and skinny. We've been implementing new technologies in the DoD with a forklift and a bag of money for the last 30 years. I mean, that's the reason why MOSA even came to play, because we can't afford it. When I was sitting in the chair on the government side, when it came to moving a radio from out of a platform and putting the newest, latest, greatest radio into that platform, the amount of NRE that was required to do it, along with the things we had to do to the vehicle in order to fit this new C5ISR capability, put us modernizing technology like we were modernizing a tank. So a 7-year time period to get a new radio into a platform. So that's the biggest thing. We got to get beyond forklifts and a bag of cash, and not seeing, and even with that, the glacial motions that it took, that it ended up taking to get from radio A to radio B, just wasn't sufficing the operator.
And how are you approaching I agree. This and hopefully it'll speed things up in the long run. But how do you guys approach MOSA within Ultra? I see that you joined the Sensor Open Systems Architecture. We talked about that. Can you talk a little about what you guys are doing internally?
So, and again, thank you very much. You were a great catalyst for us to get into the consortium. We've basically we've moved to open system architecture frameworks, tools that enable us to build or to refactor software that we've been building for the last 30 years, that's proven into things that can be leveraged multiple times in different architectures, both from a waveform development as well as from software piece parts. We're also doing that from a hardware perspective, so that we're building modular components with our hardware so that we can start new business lines. Like a prime example is how we're using our Hunter family of system aperture as a means to start our Archer family of systems, which is our troposcatter capability. So that's where modularity really fits. Another interesting thing is it's like we're known for our line of sight high capacity radios. So it was this big. And because of modularity and being able to refactor and use smaller parts, we've made, I got some show and tell. We actually got our smaller form factor, which is a 2-channel.
You got some blur on, so we can't see.
I got blur. Oh, yeah. Blur. There we go.
It is.
In
okay.
focus.
Yep, we got it.
So this is what we have taken from our legacy stuff and made it into a modular capability that can be used in MOSA from a digital radio head. We use that same technology, same computing resources to get to almost a similar capability in a smaller form factor. And then we took it and even went a little bit further and got into a smaller form factor, but they're all the same modular components. That's what MOSA has driven us to do. And it's working pretty well.
Yeah, and it's interesting. I know you mentioned earlier, and like the government's already pushing for MOSA. The generals want MOSA. They say, how can I get MOSA? What is this MOSA? What is the plug and play? I'm hearing that on the floor of AUSA, AOC. And what I also heard was from some folks is that they're not waiting for the example of SOSA, for some things to even finish their conformance process within SOSA. They want SOSA aligned. They want something that has a bit of that content now. And in some way, that reminded me of JTRS, where this program that took forever to put together, but yet Harris went off and made the radios, and they're the only ones really still making it. So they just went right to the bit. The DoD wants it now, even though they say it's going to take a long time. So do you see that dynamic as well? Is that kind of what you guys are doing when you design products? You know they want it now, right?
We are. We know they want it now. Like you had a prime example. So I was on the government side when the JTRS battles were happening, and actually I was one of the first adopters of the 117 Golf into in the ANW2 architecture. We gotta be thinking ahead of the need, and that's what's going on in the government right now. Is we're transitioning to more of a product focused environment where we need the whole of industry to be investing in what's next so that we can reduce the time in which it takes to be integrated into the architectures to be of value to a soldier when they're at the tip of the spear.
Okay, so that talks about the value, and some DoD leaders I know have called for more metrics on MOSA. How do we combat the naysayers within the DoD? So how would you describe or measure the success of a MOSA initiative? How do you combat the naysayers? Because you're a fan.
So here's the starting point. Plugfests are the starting point. We have to get from theory to ratification to actual realization. Similar to what they do in the cellular network when it comes to handsets, as we've grown to where we are right now. Plugfests are still kind of lab activities. However, it lets us know what the feasibility of the standards are, and it starts to get after the affordability. So if it's too expensive for me to realize so that I can put it into a lab and put it into multiple chassis and they all work together, then most likely it's too expensive for me to put it out on the battlefield. So that's the first thing. Plug first comes first. The second thing, the true measurement of success is when some soldier or airman or Marine can rip out a card and put in another card and not have to use a bunch of forklifts to get to modernization.
That's a really good point. I often hear it described as when we see the money hit this certain point, we see the savings. Maybe it's because of your background, but you talked about, well, the guy in the field can just plug and play, literally pull it out, put it back in without any downtime for the whole system, without having to send it back for maintenance. I guess that's another thing. It comes to sustainment as well, right? It's an example of sustainment reform in a way, right?
Yeah, that sustainment reform it's going to be a fun task. I say that it's a lot to poke at there.
We talk about commercial technology, and most initiatives are definitely enabling more commercial technology to get into military systems. But with that, does the DoD acquisition process need to speed up to truly take advantage of commercial innovation? If yes, how so? And I know this is a hottest of all topics right now with what's going on in the U.S.
It is a hot topic, and here's how I put some thought about this while I was on a number of plane rides this week. Long and skinny, and I said that once before, when we can move from a model where it's less about the program and more about the portfolio, then I think that's the reform that is gonna get us the biggest bang for our buck. And here's why. Because programs get too big to fail. And because they get too big to fail, we spend a lot of time propping up the one thing that's keeping us from getting across the line, although the technology or the implementation might be OBE. If it goes to a portfolio management process and it's about getting the capability as fast as we can and willing to fail fast, I think that will enable us to get commercial technology out to the field. But that's the mindset change that has to happen in acquisition, in requirements generation, the whole nine, in my opinion.
Yeah, it does. I mean, and it's not easy to change the DoD, and that's why we have all these new examples of like the dusting off OTAs. They have the SOFWorks, they have the Rapid Equipment Force, DIU, SDA. You can't change the base, although that's what this administration is looking to do. And things are moving fast. We and I both talked about. Everybody's talking about it right now. Do you have any inclination on how the incoming the current administration, not the incoming administration anymore, how the current administration will prioritize technology investment while also cutting costs in the DoD?
Again, going back to that last statement, going from programmatic to acquisition, you make those type of reforms. So here, this is just Clif's view of the world currently. If I move from programmatics to portfolio management, and then there are technologies that can be used by all the services. There are things such as every service needs a network. Every service needs some way to defend against counter UAS or against adversary UASs. Everybody needs autonomy. So these are all things, regardless of what service you still need. Now, if I can take a DoD wide approach to acquiring or delivering, acquiring those capabilities, and doing the delivery, be able to shape the execution of that technology so that it enables that service to do its part of the joint mission, then innovation may survive the cuts. So, but it's a whole of DoD. So again, those are some things out there that everybody needs. And from a technology perspective, I'm going to say all of this knowing that this has been done before. We've tried this before. It was the JPEO, JTRS was a all of government approach to getting to software defined radios. And it didn't go that well, mainly because we were focused on the government way of doing it, where we took a lot of government dollars against this thing and requirements against this thing and kept propping it up, regardless of how how well the technology was maturing. And the rate of maturation is happening so much faster than it was 20 years ago. So maybe an approach like that would survive in this time.
And I also think there's pressure. They see the success of, like you mentioned, counter UAS and UAS deployment in Ukraine and things like that, and how quickly they field that. So I see that a lot. A show we tend to, you and I talked about the other day, was Soft Week. That's a big growing part of that area, is UAS, counter UAS for special forces, and also AI. But and obviously open architectures. But aside from open architectures, what are some of the design requirements you're getting from the DoD for your tech? What are some of the trends you're seeing?
So the things that I'm seeing is I kind of fought between two words when I started thinking about this. So you have modularity, that's like the given, and now is adaptability. Adaptability is how can modularity being taking X product and being able to leverage X product across multiple architectures, but I'm getting that same thing, right? Now, adaptability is, now that I have X product, how can I modify it to do an adjacent mission? Something that is core to its capability, but it's not necessarily turned to. Where we're seeing this at is a lot of in the area of like every radio is a sensor, where I got this capable radio that I'm using to provide connectivity, which also has duty cycles in which I can use it to get situational awareness on this individual in this invisible domain that we call the electromagnetic spectrum, that I can start using to help me shape this new domain of fighting. So that's the adaptability, and it also lends to another word, which is convergence. Like we've been hearing terms like communications, electronics, convergence, because if it's a radio and I can transmit to create a communications channel, I could probably use that same capability to put electronic warfare signatures on air, because I'm still transmitting. So that's where I feel like there's another bang for our buck if I got the same piece of equipment that's in the hands of a communicator, that's in the hands of a cyber warrior, that's in the hands of electronic warfare, and everybody gets that level of training on it, then I can leverage that piece of equipment to do all of these things. That's convergence. So those are the two terms outside of modularity I'm hearing the most from customers.
And you shared with me a term last month, or no, this month, when I saw you at West in San Diego. You mentioned something called sentient radio. Can you tell us what that concept is about?
Okay, yeah. So this is something I've been brewing in my head for I feel like it's been the last 10 years. I just hadn't been able to coin a term around it.
Is it different than cognitive radio?
Yeah. So 1998, Dr. Mottola, before, when he was doing his thesis, coined the term cognitive radio. And the reason it kind of came about, because you got to look at the time, it's 1998. The biggest radios that you had right now on a tactical battlefield with Sengars and EPLARs. There was a lot of a lot of data loading you had to do into that radio to create a link between two sides, right? And then if I had some kind of abstract obstacle between those, I had to put relays in place, and there was a lot of cognitive load on the signal layer to establish a network that could support the operation. We are moving out of an environment where, and from that, let me correct that. And from that was the advent of MANET. So mobile ad hoc networking that was kind of what the DoD community said, this is the goal line you need to go across to get the cognitive radio. So it may not have been the good doctor's whole theses around cognitive radio, but that's where we ended up. And for the last 20 years, that's kind of the race that's been going on. I've been a part of this software-defined radio, cognitive radio realization since 1998, 1999 through Force 21. And MANET has been kind of the thing the goal line that if you could get across, you hit the cognition. But that's not enough anymore. In the battlefields of today and tomorrow, as we're seeing in both Ukraine and as well as in the early days of the Israeli-Hamas fight, is that I need resources, computational resources and RF resources that allow me to go across the spectrum, have as much frequency agility, to have as much computational power to instantiate multiple waveforms, multiple topologies, to truly create a hyper-connected architecture of both machine and humans. So I move beyond cognitive, the way that we the DoD and the defense community have given the goalpost for. And now we need, in order to survive the threats, the cyber threats, EW threats that are being seen today and that will follow us into the future, we need that. And that's what a sentient radio, that's a class of radio that we're transitioning to from cognition.
Is it AI radio too, in a way?
Oh, so again, we're not building the AI for the sake of AI. I mean, it should be, we're productizing it along because it's a computational resources. I'm using neural networkings in order to determine the conditions that's going on around me. I need to be able to sense the environment to the point, and then be able to use those resources, RF and computational, to instantiate the right waveform, the right topology, and the right survivability overlays. Maybe it's LPI, maybe it's LPD, maybe it's spread spectrum, so that I can continue to maintain that link for the mission. So that's where I see that we are moving beyond the cognitive radio classes of radios, and that's where we've been focusing a lot of our intellectual capital and our development around this new class.
Do you have a timeline at when you'll start maybe showing some designs or rolling stuff out along those lines? Or
oh yeah, I'm rolling out stuff now.
You're rolling stuff down.
I'm rolling out stuff now. We're starting to get some really good early feedback on the first green box that I showed you that was blurred out, where all of those piece parts are in there. I have a acceleration. I have frequency ranges down to from L, S, and C band. I have computational resources that can run multiple channels, multiple waveforms based upon, and able to sense the environment around me and actually say, okay, based on this and what's coming in from the operator from a data perspective, and what we're calling these are data-centric waveforms that we're instantiating. We're rolling out. The goal is to start popping this into a theater near you very, very soon.
Well said. And so a lot of new tech out there, but one of the things, this is one of my favorite questions, and I've been wanting to ask you this one, is we talk about new technology, Sentient radio, we're talking about MOSA, but what about new engineering talent? I mean, there seems to be a lot of gray hair like mine and like you have in your beard and at shows like at AOC, FCOS, wherever it is, as opposed to non-defense shows. So how does the defense industry have a talent recruitment problem on its hands? And if so, how can it be solved? And how do you guys do it?
All right, so you're absolutely right. At one point in time, I was the young guy. I mean, and honestly, I still kind of missed that turning point where I became the gray beard. And so it's cool. I am now that guy. But it was a struggle even when I was a kid. I remember when I first started this journey around 21, 22, there wasn't a lot of people my age that wanted to kind of spend their time in defense tech. There were so many other things moving. And you got to think, even back then, we were still building green boxes, like hardcore green boxes, right? Today, it's getting harder. MOSA is a pivoting point for us because once we start mothballing the forklifts that we have out there trying to do modernization, well, enabling us to do the modernization that we're doing today, and we're moving into these modular open systems architectures, we're going to be building off of frameworks that they've been taught that's relevant to this new generation right now. So if we build it right, they will come. So we get rid of the forklifts. We start leveraging the frameworks, the standards, the open source tools so that we look more like them when they come out. Then that's how I think that's how it happens. From what I feel like we're kind of unique, especially on the comm side, because we have this 100 years of Marconi legacy that we have behind us. So the way we're attracting is by we're giving new entrants a foot in two worlds, both in the past and in the future. The past has a lot of lessons that can be learned from. And I mean, back from the first HF wireless link that was transatlantic that happened under our company's umbrella to the Sentient radios that class of radios that we're looking to push out. I feel like we're giving young folks the opportunity not to throw out all the babies with the bathwater, to say, because sometimes that's what happens when you're doing new entrants. It's like, here's what we learned from the past. Here's what we're learning from the future. And here's how we deliver today.
So you're giving young engineers a problem they probably want to solve.
Yeah. And that's, that was another kind of thought I had when I was flying this morning, is that we want to start presenting them actual hard problems. A lot of them kind of look at us and say, we're still solving these, things that are 10 years in the past, and why do I want to waste my time? I think we're starting to truly see the new problems.
So as we get my last question, and you might have already answered it, but what is a disruptive technology, innovation, or initiative that you see being a game changer in the defense electronics world? I mean, predict the future. Is it sentient radio? If so, or is it something else? What do you see?
Okay, of course it's sentient radio. All of my Orion products or families are going to be based off of it. But actually, I kind of looked at it in two different ways. And this is because it's an old problem that we still don't have a really good solution. We don't have the future. And that's the harvesting and storage of power. You can't have continuous operations. Regardless of how good my radio is, if I don't have the appropriate power source or the right amount of power for you to get through a mission load, or if I'm overloading you because you got to carry 1 million batteries, or you got to bring this huge distribution system to go along with it, we're going to run into failure points. So you couple that with math, human to machine teaming. Those two things are when it comes to defense electronic or defense tech, that's the big thing. And when I envision future, I think of the movie Ender Games. Like, when I can see that those large movements of robotics being manipulated to win an obstacle, when I have 3 or 4 people sitting back at some command post orchestrating all of that. So that's the future. That's what we want. But we can't get enough power to the fight. And then all of the necessary connectivity, hyper-connected architectures that go along with making mass amounts of robotics connected to small centers of human capital to speed the battle along. So those are my thoughts.
Okay, well, we'll look forward to see if it comes true. I think it should. I mean, those are predictions. Those are also, I think, hopes that we have, because those are problems that need to be solved. So, yeah, without a doubt.
And we're solving it you're seeing definitely the onset of it, like what we've seen in Ukraine, and how basically every soldier has at least 2 UASs associated with them. Now think about, hundreds, thousands moving in concert based upon the right human capital behind it.
Yeah, each person has a swarm of their own, so to speak.
Based upon battlefield functional area.
Yeah, exactly. Well, that brings us to the end of the broadcast today. Clif, thank you so much for speaking. I always enjoy talking to you. I learn a lot. I hope the audience did too. It's been a lot of fun.
It's been a lot of fun. Thanks for your time and look forward to seeing you at the next show, my friend.
Absolutely. Thank all of you for listening today to McHale Report Podcast. Look forward to seeing you on future broadcasts. Thank you.